Hey guys, this is Mr. Grice for Algebra 2, Chapter 8.4 Notes. Today we're talking about adding and subtracting rational expressions with unlike denominators. So, in order to add or subtract fractions, they must have a common denominator. And to obtain that common denominator, you are allowed to multiply each numerator and denominator. Okay, so let's look at example number 1. It says 3/4 plus 1/12. Now, if you don't know what the lowest common denominator, the LCD, what we do is we take the multiples. So there's 12, 24, and then you would start with 4, 4, 8, 12, and then as soon as you have a common number, that's what it is. All right? The 1/12 we don't have to change. But the 3/4 we have to multiply it. And we would multiply by 3. And that would change to 9/12. We would add it, the numerator changes and the denominator stays the same. And then we always want to see if we can reduce it. And in this case, we can. Then our final answer would be 5/6. All right, let's look at example number 2. So once again, we got to find a common denominator. So we're going to do the same thing. Take the multiples, because some people are like, oh, it's 24. Well, that is a common multiple, but it's still too high. As soon as we find a number in common, that's what we use. Okay? So for our first fraction, we actually have to multiply that by 2. And we get 6/12 minus, and then we have to multiply by 3. And we get 3/12. So when we subtract those, 6 minus 3 is 3, and the denominator stays the same. When we reduce that, because we always reduce our answers, we get 1/4. And that's our final answer. All right, so today we're going to be doing the same thing, except now they're going to be rational expressions with polynomials. So before you can add or subtract rational expressions, you need to find the least common denominator. Okay, so that's the first thing, least common denominator. And you need to ask yourself, how can I get the denominators to look exactly the same without taking any factor away? So to do that, we have to factor each denominator if possible. And then the LCD is made up of all the factors required to make the denominators look exactly the same. So I know it sounds a little difficult or confusing, but once we go through a couple of examples, you should get the hang of this. Okay, so the first thing, we are only trying to find the LCD. Okay, so step number 1 said to factor. When I factor, this equals 2 times x. And when I factor this, this is x times x. And I want them to be exactly the same. Okay, so what do they have in common? Well, they both have an x in common. So that's going to be part of my GCF. Okay, but this one has a 2, and this one has an x. So our GCF, or our LCD is a combination of both of those. Okay, so now my LCD would be 2x squared. Okay, because that's a combination of that. let's look at the next one. All right, I am going to completely factor this. Okay, 6 is 2 times 3, and then we have 3 x's. The 4x is 2 times 2 times x. So right away, what do we have in common? Well, I've got a 2 and an x. So that's what's in common. Now, I need to add a 3 and 2 x's. And over here, I need to add a 2. So our LCD is a combination of all of those. 3 times 2 times 2, well, that's 12. And how many x's do we have? 3. So we get 12x cubed. Now, let's look at number 3. I can't break down x plus 1, and I can't break down x minus 2. So my LCD is a combination of those things, okay? So it would be the x plus 1 and the x minus 2 together. So we would just say that it's x plus 1, x minus 2. All right, number 4. It's the same thing. We can't factor the x minus 1, and I can't factor the x plus 4. So my LCD would be a combination of those, which would be x minus 1 times x plus 4. Okay. Now I can start to factor. I can pull out the GCF of 2, and we're left with x plus 4. Well, this guy is just x plus 4. So what they have in common is x plus 4. But what I need to add, I would need to add the 2. So my LCD would be what I have at the bottom, would be the 2x plus 4. All right. Once again, the first step is to factor. So I can factor out an x, and we'd be left with x plus 5. Our second fraction is just x plus 5. So what do they have in common? Well, they have in common x plus 5. But I would need to add that extra x there because they both have to be exactly the same. Okay? Because if they're not exactly the same, we can't combine them, and that's what we're trying to do here. Okay, a couple more. All right, so we need to factor this. I need numbers that multiply to get to 8 and add to get to -6. And that is -2 and -4. So this would break down to x minus 2, x minus 4, and that x plus 4, yeah, we can't break that down. So do they have anything in common? That's what we have to ask ourselves first. And they don't. So my LCD would be all of that, the x minus 2, x minus 4, and x plus 4. Okay, last one on this side. So x squared minus 64, that breaks down into the difference of two squares. So we have x plus 8, x minus 8. And here we just have x plus 8. So in common, they both have x plus 8. But we need the other one to have an x minus 8 as well. So our LCD would be x minus 8, x plus 8. Okay. Well, guys, that's the first side. And here, all we were doing was trying to find the least common denominator. On side number 2 is when we take it to the next step where we actually multiply and then combine. Okay? But we'll do that in a whole nother video. So this was Mr. Grice for Algebra 2, Chapter 8.4 Notes, video number 1. Thanks for watching.